So now the question is, can we have mixed data type in a NumPy array? So there are different data types like int, float, string, boolean. Okay, can we mix them in a NumPy array? So in theory, yes, we can have mixed data types in NumPy array, but there are some caveats. So by default, NumPy arrays are designed to be homogeneous, meaning all elements should be of the same type. If you try to create a NumPy array with mixed data types, NumPy will automatically upcast the array to the least common type that can accommodate all elements. Okay. Example, if you mix integers and floats, the array will become a float. If you mix numbers and strings, the array will become of type string. Okay. So you can see examples here. Here I have mixed integer, float and string. Okay, so the data type which can accommodate all three is a string. That's why everything has become a string. So when you see this U32, so basically it's a Unicode string. Okay, now if you mix let's say integer and floats, then everything will become a float, right? If you mix integer and boolean, okay, then everything become integer, and these booleans true and false, so true will convert into 1 and false will convert into 0. Okay, similarly if you mix string and boolean, everything will convert into string. So you can see this U5 which stands for Unicode string. Okay, so now this true and false have also become a string. So yes, in theory we can have mixed data types in NumPy, but it actually hits the performance of the NumPy arrays, and I will recommend that we should not mix data types in NumPy array. So in this tutorial we are going to learn about indexing and slicing of NumPy arrays. So basically indexing and slicing allows you to access and manipulate specific elements, rows, columns or subarrays. So we'll start with the examples, because it's easy to explain these concepts via examples instead of just talking to you. Okay, so there is a one-dimensional array here. We have to find this one-dimensional array. Now we want to access its specific elements. If you want to access the first element, which is 10, then we want to access the third element. Basically, so just like Python lists are 0 index, the NumPy arrays are also 0 index. So to get the third element, you need to use index 2. Okay, so the output will be 30. Now if you want to get the last element of the NumPy array, you can use the -1, just like simply like the Python list. Okay, so this is the one-dimensional array indexing. Okay, now for two-dimensional array indexing, let's say you want to get the element at the first row and first column. This is the first row and first column. Okay, so first row, first column, 0th and 0th index, 0 for row, 0 for column. Okay, now if you want to get the second row and third column, so second row and third column. Similarly, if you want to get the third row and last column, element at third row and last column, for last column you use -1, for third row you use 2. Okay, now let's see how we do the slicing. So by slicing we mean like we want to create a sub array from our existing array. Okay, so if you want to get all the elements from index 1 to 3, this is how you can get it. Okay, so you will get the output as 20, 30 and 40 for this row. So you can look at these examples. If you want to get all the elements up to index 2 from the start. Okay, these three elements from the start up to index 2. Okay, 0, 1, 2. This is the syntax for that. If you want to get the last three elements from the array, you do this -3:. Okay, similarly we can do two-dimensional array slicing. You can read these examples. Just pause the video, read these examples, you will understand them. Look at the comments also that I have added. It will very easily explain you what's happening. Okay, now let's look at this Boolean indexing concept. So basically in NumPy array you can in fact give some kind of condition to filter out the elements. You see, I want to get all the elements which are greater than 30 from this array. Okay, so the syntax for that is like this. Okay, you can also cherry pick elements from different indexes and create a subarray. Okay, so you want the second element, fourth element and fifth element. Okay, second element, fourth element and fifth element, 20, 40, 50. That's how you are going to get it, second, fourth and fifth. Okay, now if you combine slicing and indexing, so just go through this example and look at these comments that I have given here, you will understand what I am doing. So that's all for slicing and indexing of the NumPy arrays.